Here we have before us four different types of matter. So being matter, they all occupy space and have mass. And so this is just kind of the setup of a demo that I used to do in class. There's kind of two different versions of this particular demo. First of all, it's important that you recognize that matter comes in different phases. This is pretty obviously. Both of these bits of matter are in the liquid phase. These two bits of matter are in the solid phase. You'll notice that each pair contains just about the same amount of liquid, and these two solids are just about the same amount of space occupied. In other words, their volumes are just about the same. The thing that's really different from these two things is if you try to pick up this bottle, it's very, very easy to pick up, and that's because it's water. This particular bottle is really hard to pick up. And I don't know any real good way to show you this, but in class I used to find the biggest, toughest looking guy, and I would give them this container to hold, and inevitably they'd either drop it on the ground or have trouble holding it, and then I'd find like the wimpiest person in class that I could find to give this to, and it would be pretty obvious that they had no problem carrying that, and so I would just use that as a way to insult the big guy that could probably beat me up. So anyway, here you obviously can't feel how heavy these things are. So what I did was I grabbed the little balance out of your lab kit, and hopefully you'll be able to kind of read the numbers that are associated here. So these both contain different amounts of mass. Keep in mind that mass is kind of the junk in the trunk. It's the amount of stuff that you can actually pick, kind of pack into a given area here. So that guy is about 113 grams. This guy is so incredibly heavy it actually makes the scale malfunction. So I should mention that concept of density, that is a really important physical property, is pretty different here. Water is right around 1 gram per cubic centimeter, whereas this, you can see written on there possibly, is about 13.53 grams per cubic centimeter. So what that means is that there are a lot more atoms, really, or there's a lot more mass in this guy than there is in this guy. It's actually untrue what I said about atoms, but when we start to talk about atomic structure, we'll find out, how do you get so much more matter into this guy, or so much more mass out of that same volume of matter of this guy relative to that guy. Another really fun demo that I used to like to do is we have what looks like two rocks, but you'll notice that the amount of mass, or the stuff contained them, is very different. That one's around 42.4. This guy, I don't think it'll make the scale malfunction as long as I don't destroy the scale. Is about 530 grams. And so what I used to famously do with this is I'd carry both of these rocks kind of in front of the front row, and I'd pretend to trip. And of course, this guy, who weighs basically nothing, it's just like a little scrunchy guy, would make people in the front row dive out of the way. And of course, if I had done it with that guy, probably would have killed somebody. No more lawsuits, please.